Okay, we are starting on Unit 9, Chapter 9.1. Let's start with some review questions. Name 3 ways to classify a triangle by its sides. Keyword sides. And we want to classify the 3 ways are we can have an equilateral, we can have an isosceles, and we can have a scalene triangle. Remember, equilateral, all sides the same. Isosceles, 2 sides the same. And a scalene, none of the sides are the same. Okay, next one. Name 4 ways to classify a triangle by angles. Key also angles. So there is a right angle triangle, or you can have an acute triangle, or you can have an obtuse angle, or last way, which we don't usually use often, equal angular is just another fancy way of saying all the angles in the triangle are the same, and all equal angular triangles are also acute triangle. So we look here at this triangle, notice that none of the sides are the same length, and it has a right angle in this. So this is a right scalene triangle. And here, this is a leg in the right scaling. So let me write this in a different color. So this is a leg of a triangle. And this is the leg. And whatever is opposite from the right angle is it's the hypotenuse, or the longest. But this is the hypotenuse. Or the longest leg. So here. Next, the leg of a right triangle is the sides of a right triangle that makes the right triangle. So here, if I name this, so if I call this, let's say this is A, B, and C, the legs would be AB and BC from that picture. The hypotenuse of the triangle is the longest side of a right triangle, opposite from the right angle. So the hypotenuse in this case is AC. Today, the most important thing that we are going to learn from this entire unit is our Pythagorean theorem. And the Pythagorean theorem uses this particular triangle, the right triangle, to find the missing side of a right triangle if you know the 2 of the 3 legs. So if you know any 2 of the 3 legs, or the 3 sides of a right triangle. So here, it basically says if we have a leg squared plus another leg squared, it equals the hypotenuse squared. And we normally, it's called leg, and hypotenuse, but normally we call those A and B because each leg is a different sector. So we call this A, this B, and then we normally call the hypotenuse C. So C squared is your hypotenuse. So let's label the legs and the hypotenuse and find all this stuff. So I'm going to call this one A and this one B. This is another leg. And this one C because that's the hypotenuse because it's opposite from my right angle. So here, A squared plus b squared equals c squared. This gives me x squared plus 6 squared equals 10 squared. X squared plus 36 equals 100. If I subtract 36 to both sides, x squared equals 64. If I square root this, both sides, x is then 8. That means this leg equals 8. And we can do it the other way too. So here, I'm going to call this A, I'm going to call this B, and the hypotenuse is C. So A squared plus B squared equals C squared. 9 squared plus 12 squared equals x squared. This is 81 plus 144 equals x squared. This becomes 225 equals x squared. If I square root both sides, x equals 15. Okay, move on down. Let's keep doing other examples. I'm going to call this A, I'm going to call this B, and I'm going to call this C. So this is 1 squared plus 1 squared equals x squared. 1, so that's 1 plus 1 equals x squared. So that's 2 equals x squared. I need to square root both sides. I cannot do anything to the square root of 2. It doesn't make a nice number, so I'm just going to leave it as the square root of 2. Okay, my hypotenuse is opposite, so I'm just going to call this c squared. Or c, not c squared, but I'm going to call that c. I'm going to call this A, B. So 4 squared plus 8 squared equals c squared. This is 16 plus 64 equals c squared. 16 plus 64 is 80 equals c squared. So then c equals the square root of 80. I can simplify 80 because if I think about 80, 80 is just the same as, let's see, if I broke down 80 into what? 80 is 5 times 16. 16 is a perfect square because if I square root 16, it's 4. So then C is 4 root 5. Or if I break this down, this is 4 times 4. And this matches. So I have 2 pairs. I pull out that 4. I'm left with a 5. Let's try another one. I'm going to call this A, B, C. So this is x squared plus 6 squared equals 24 squared. X squared plus 36 equals 24 squared is 576. Subtract 36 to both sides. X squared then equals 540. If I square root this, let's try to pull some perfect squares out of 540. Let's see here. If I break down 540, I know that 9 times 6 makes 54. And so 9 times 60. And I know 9 is a perfect square, so I'm just going to circle that. 60 is 6 times 10. But I don't have any perfect squares there, but 6 is also 3 times 2. And this is 10 is 5 times 2. I got 2 pairs of 2 right here. If I square root 9, this becomes 3. So I got a 3 and a 2, and I am left with a 3 and a 5. So this is x equals 3 times 2, and I'm left with underneath 3 times 5, which is 6 root 15. Okay, number 6, I'm going to call, this is my C right here. Call this A, B. So x squared plus 64 equals 21 squared, which is 441. Subtract 64 to both sides. X squared equals 377. I want to square root 300. 377 does not have a perfect square in it, so x is just the square root of 377. So these are my answers like so. Here, last thing, we can use this if we just have 2 points, right? If we have 2 points, we can draw a right triangle like so, and that will give us, we can use the Pythagorean theorem to find the distance, to find this distance, which I'm going to call C. I'm going to call C, and this is 3 units, and this is 1, 2, 3, 4, 5, 6, 7. This is 7. So then 3 squared plus 7 squared must equal C squared. That is 9 plus 49 equals C squared. That's 58 equals C squared. 58 doesn't have a perfect square in it, so C equals the square root of 58. Last one, if I had this is a 3 and a 3, and I want to find C. So then 3 squared plus 3 squared equals C squared. 9 plus 9 equals C squared. That is 18 equals C squared. 18, I know, if I'm square rooting this, 18 is 9 times 2. 9 is a perfect square. If I square root that, I get 3. So this is 3 root 2. The 2 stays behind. So my 2 stays behind.